Hello everyone, welcome to Study Zone. Today we are going to solve some more problems on discrete mathematics and optimization. Under that we are going to solve the problems on logical equivalences. So you already know about all the laws, right? If you don't watch the video of that one, please go through the previous video and watch all the videos on the laws and then come back to this video. So now we have the first problem as P or Q or not P and not Q and R is logically equivalent to P or Q or R. Correct. Now we have to take RHS part, that is P or Q, R, not P and not Q and R. Right. So we have to take this one and solve, and we have to check whether this side is logically equivalent to this one. Now look at this. Here P or Q, we can't apply any laws here, so write as it is, and then R same as it is. And now look at this, here we have not P and not Q. Now I remember one law. Which one law? De Morgan's law, correct? De Morgan's law. What does De Morgan's law suggest? It tells us that negation of P or Q is equals to negation of P and negation of Q. Correct. If we reverse it, what will it be? Negation of P and negation of Q equals to negation of P or Q. Symbol changes. Correct. Now we are going to apply the De Morgan's law here. It will be negation of P or Q. This one same as it is, and R. Done. Now look at this. Here we have P or Q, and here we have negation of P or Q. Here we have and. Correct. Look at this. Here we have plus symbol and here we have multiplication symbol. So it will be like A plus B into C. So what is A plus B into C? A plus B into C equals to A plus B into A plus C, right? So now we are applying this one here, that is A plus B into A plus C. Done. We are substituting for this one, A plus B into A plus C. Now look at this. Here we have P or Q, and here we have negation of P or Q, and here we have R, that is plus symbol. So if we got anything like this, what we have to do? We have to apply this for truth table, right? In the previous examples we have P or not P, but here in the place of P we have P or Q, correct? So take this one as P and this one as negation of P. So P, negation of P. What we have to do? We have to apply R symbol, that is P or not Q. R means plus, right? So true, if we take P as true, what will be negation of P? It will be false, correct? So true plus false will be true, which means 1 plus 0 will be equals to 1, right? And then take P as false, false and then true. False plus true is true. So if we take anything in the place of P and Q, we will get the answer as true, correct? So substitute true here. And now look at this. Here we have P or Q or R. So write like this, P or Q or R. Now look at this. Here we have true and P or Q or R. So now again apply truth table. So take this one as Q, okay? Now apply truth table, that is true into Q, right? So now first take this one as true, okay? True into true, which means true means 1, correct? 1 into 1 will be 1, no problem. And then take Q as false, that is true into false, which means 1 into 0. 1 into 0 is 0. So it is completely dependent on Q, right? Here Q means P or Q or R. So we can remove this one and take it as P or Q or R. Now look at the RHS. Is it is same? Yes, it is same. So hence our proof, that is LHS is logically equivalent to RHS. So this is the solution for first problem. And the second problem is show that P and Q implies P or Q is a tautology. Here we have to prove that P and Q is implies P or Q is a tautology, correct? So here look at this, here we have implies symbol, which means we have to apply implication law. What does implication law suggest? It tells us that P implies Q is equals to negation of P or Q, correct? So take this one as it is, and now here for this implication symbol we have to apply this one, that is take this as P and this as Q. P implies Q will be negation of P or Q. Done. Now look at this, here we have negation of P and Q. Now what we have to do? We have to apply De Morgan's law, right? What does De Morgan's law tell? That is negation of P and Q will be equals to negation of P or negation of Q, correct? Here symbol changes. So negation of P or negation of Q, or as it is, and then P or Q as it is. Now look at this, here we have R symbol, here we have R symbol, and here also we have R symbol. So what we can do? We can take this one like this, and then we can take these both and write it like this. That means negation of P or P or negation of Q or Q. If you see negation P is together, we have to apply truth table, correct? So now let us apply truth table, that is P negation P. What we have to do? We have to do OR operation, that is P or not P, which means if P is true, then negation of P will be false, correct? True plus false will be true. If we take P as false, then negation of P will be true. False plus true will be true. So whatever we take the value of P and negation of P, our answer will be true. Done. Now this part, that is negation of Q or Q. Same thing, we have to apply truth table. Q, not Q, Q or not Q. If we take Q as true, negation of Q will be false, and true plus false will be true, correct? And the next step is what we have to take? We have to take Q as false, correct? False, negation of false will be true. So false plus true will also be true. Same. Whatever the value of Q, the answer will be true. So true or true, which means true or true will be 1 plus 1, which is equals to 1, because truth value has only two value, that is 1 or 0, correct? Which means true. Hence it is tautology. Tautology means all the equations or all the values will be true. Hence our proof. This is the solution for second problem. Thank you.